In this video, we're going to be going through section 5.4, which is about probability density functions. And what this is it's how integrals relate to the field of statistics and probability through primarily what are these probability density functions. So what are these? You may have heard of what's called like the normal distribution or the standard distribution. This is the most common type of probability density function. Which is often called the bell curve because it kind of looks like this bell shape. And what a probability density function is it relates the probability of an event with the area under the curve for a given function. So take this standard distribution, for example. How a standard distribution works is the closer you are to your average value, so this is your mean, this axis right here is going to represent our mean. The closer you are to your mean, the more common the result is, but the farther you are away, the more extreme values are less common. Think human heights, right? If you're average height, there's a lot more people that are average height than there are people who are super tall or super short, right? Those type of people are more rare. The more extreme values are less common. The more average values are more common. And think about how that's different than like a random number generator. With a random number generator, if you're picking a number that's close to the average number, that's just as common or likely of an outcome as picking an extreme value because it's random. Anyway, so this is the standard distribution. And so what a probability density function, the fact that it's a probability density function, what that allows me to do is if I look at the area under the curve, what that allows me to do is that allows me to find the probability of the outcome falling in this range. So that's what the area under the curve represents, which means that if I know integration, if I know how to find integrals, then I can actually find that probability value. I can actually figure out what percent chance it is that the event will end up in this certain range. So let's summarize this a little bit. So let's say I have a probability density function. We like to use P of X, P for probability. So let's say we have a probability density function. Then if you take the integral of your probability density function from A to B, what that will give you is the percent chance that the outcome will occur in the interval A to B. So let's look at an example of this. So for this example, I'm using an example from your homework. I'm going to change the numbers slightly, of course, but let's say we have a probability density function for the failure of a machine. And it gives me this probability density function of 1 over 50 e to the negative 1 over 50x. So there's my probability density function. And let's say I ask the question, what are the odds, or you could say how likely is it that the machine will fail in under, let's go 20 hours. And let's go ahead and say X is time in hours. So you'll notice in this question that I'm giving you, I'm really giving you an interval of time. I'm not giving you a specific single point in time. I'm giving you an interval under 20 hours. So with that in mind, what would my interval be? Right? Coming back here, right? Probability density function, by integrating a probability density function, I can find the percent chance that the outcome will be in a certain interval. So what's my interval in this case? Well, if I'm just looking at under 20 hours, I'm going from 0 to 20. So what that means is I can set up an integral from 0 to 20 of my function and then integrate it. Okay, I know how to integrate these functions. When I integrate this, first of all, I can just keep the constant on the outside and then just integrate this piece. Integrate that piece, that's just e to a constant times x, so I'm just going to divide by that constant. So I'm going to divide by negative 1 over 50. Well, that's the same thing as just multiplying by negative 50 over 1. And then I keep everything else the same. So I'm left with e to the negative 1 over 50x. So that's what I get when I actually integrate it, and then I have to use those bounds from 0 to 20. What does this simplify to? This simplifies to negative e to the negative 1 over 50x from 0 to 20, and then I can plug in my bounds. I get negative e to the negative 2/5. That's what I get when I do 20 times 1 over 50, minus negative e to the 0. Right? Negative 1 over 50 times 0 is just 0. E to the 0 is just 1, so I get negative e to the negative 2/5 plus 1. And when I plug this into my calculator, I get 0.33. Well, notice, what does this look like? This is a decimal that's between 0 and 1. What does that mean? This is a percentage. So like I said, this should give me a percent chance or a probability. So all I have to do now is just convert that into a percentage and I have my answer. There's a 33% chance the machine will fail in under 20 minutes. At this point in the video, I started referring everything in terms of minutes instead of hours. This is all supposed to be hours, not minutes. But for the rest of the video, I'm going to be talking about it in terms of minutes. Please just understand this was a mistake on my part. I apologize. Perfect. So that's how probability density functions work. You can take the integral for a specific interval to see the probability that the outcome will be within that specific interval. So let me ask you this question. Let's look at all of my possibilities for the same problem. So going back to this machine failure problem, sticking with it, what are my possible values? Well, theoretically, this machine could work forever, right? We can't really put an upper limit on this machine. It could just keep puttering on if the machine holds up, right? So theoretically, the domain for this example is 0 to infinity. Those are my possible values that I can plug in. So let me ask you this question. What would happen if I integrate this function over its entire domain? Well, it's a probability density function, so what should this integral tell me? It should tell me the probability or the percent chance that the outcome will fall within this range from 0 to infinity. Well, what's the probability that this machine lasts anywhere from 0 to infinity minutes? What I've done is I've looked at all of my possible values. The interval that I'm giving you is all of the possible values. So what's the probability? Well, it should be 100%, right? There's a 100% chance that the machine will last some positive amount of minutes. Well, I can actually verify this by using integration. Okay, this does require me to use a limit because this is an improper integral. So technically, I'm to take the limit as b approaches infinity and go from 0 to b of 1/50th e to the negative 150x dx. Luckily, I've already found the integral of this. It's just e to the negative 1 over 50x. Integrated from 0 to b. So then I can plug in those values. I get negative e to the negative 150 times b minus, well, I know what that other bound ends up. When I plug in 0, I get e to the 0, which is just 1. And since I'm minusing a negative, it ends up being a positive 1. Well, what happens as I forgot my limit. What happens as I let my limit approach infinity? As I let b approach infinity? Because I have a negative here, my exponent gets infinitely negative. And what is e to an infinitely negative number? It just approaches, this approaches 0. And so I'm left with 1, which is exactly what I want, because when I convert that into a percentage, that's 100%. So this is actually true for all probability density functions. This is a feature of probability density functions. So let me make this a little bit more formal here. If p of x is a probability density function, then the integral from a to b of the probability density function is equal to 1 if and only if a to b represents the entire domain. If you're integrating it over its entire domain, then the integral should equal 1. So I think the first two questions on our homework are you doing this very thing? It gives you a probability density function. Well, it gives you a possible probability density function, and then it has you verify that it actually is by integrating it over its entire domain. And just making sure that when you integrate it, you get 1. Consider this problem. Let P of x equal kx, where k is just some constant. And let's go ahead and say my domain is from 5 to 10. Okay, I'm integrating from 5 to 10. Those are my possible values. So whatever situation I'm working with, the only possible values I have are any number between 5 to 10. What value does k have to be in order for P of x to be a probability density function? Well, to answer this, it goes right back to this property. It goes right back to that property. In order for something to be a probability density function, then the integral over its entire domain, which is what this is the entire domain. The integral over its entire domain must equal 1. So let's try this out. I'm going to take the integral from 5 to 10 of kx. Okay, remember, we're assuming k is a constant. So when I take the integral of this, I just get kx squared over 2. And that's integrated from 5 to 10. Okay. Now I can plug in my bounds, and I get k times 10 squared over 2 minus k times 5 squared over 2. This leaves me with 100k over 2, which is just 50k, of course, minus 25k over 2. Simplify this. I have a common denominator, so I just get 75k over 2. And what do we want this to equal again? We want this to equal 1. So now I can just solve for k, and k is equal to 2 over 75. Therefore, in order for this to be a probability density function, this has to equal 2 over 75x. K has to equal 2 over 75. And now it's a probability density function. Okay, good luck on this assignment. Let me know if you have any more questions, and I'd be happy to help you out.